In this video, we're going to take a look at how we go about traversing a linked list. So in a couple of my previous videos, we looked at implementing this code that would allow us to build up a linked list by adding nodes to the head of our linked list. So if you haven't had a chance to watch those videos and you would like to watch those before watching this one, then you can find links to those videos in the description. So being able to traverse through our linked list, or said more simply, being able to visit each node in succession, is a really important operation, because once we master that operation, then we can go about maybe printing out data that may exist in each of our nodes, or we could go about finding where we should insert a particular node. The same thing goes for deletion if we're interested in maybe deleting a particular node or modifying the data that exists in all of our nodes for some reason. In all those cases, we need to have a mechanism to be able to visit or traverse through each one of our nodes. And if we take a look at the structure of our linked list, we'll notice that we don't have those index values like we did with the vector or the array. So with the vector or the array, it was really easy to set up a looping structure in which we just simply incremented that index value to get to the next element in the array or in the vector. We don't have that mechanism in a linked list, and the reason why we don't have that is because these nodes, in contrast to an array or a vector, do not have to be in contiguous memory locations. So this particular node here could be, 15,000 address spaces away from this particular node here. They could be contiguous, but they're just not required. So you're probably thinking, okay, well, we don't have those index values, but we do have this head pointer here. So this head pointer would allow us to get to this very first node. And if we're interested in accessing any of the data associated with this first node, the one being pointed to by the head pointer, we could write code like this. We could say head and then use our member access operator and then specify what data member we're interested in accessing. So this version of the member access operator only works with pointers. If you don't have a pointer here, you could not use this version of the member access operator. So fundamentally what this thing is doing here is it's dereferencing our head pointer. So dereferencing our head pointer, and we know that dereferencing just simply means that we're getting to or getting the thing that the pointer is pointing to. And I'm going to use parentheses here, and the reason why is because this dot operator here, this member access operator, has a stronger binding than the dereference operator. So we can do that and then do data. So those two lines of code, or those two expressions, are equivalent to one another. It just turns out to be much easier to write this than it does to write this. So this is really just a convenience overriding this here. Now, what about being able to access something here in the second node? Well, you could write something like this. You could say head, and then use our member access operator again, and then write next. So fundamentally what's going on there is we're saying dereference head and then access next here, and next is just simply a data member associated with this first node. It just turns out that next is also a pointer in and of itself, so you could dereference what it's pointing to. So instead of just getting the address, which is what next holds, we could dereference it to get to this actual node and then access any particular data in that node. But you can start to see that just saying head, then next, and then data it's not really a good idea, because then we'd have to say head, next, and then data to get to the third item's data members. And you can see that this becomes very complex and messy really quick. So we really don't want to follow that course of action. So I'm going to go ahead and draw a line through this, even though this is valid code. But in terms of being able to implement our traversing, not a good idea. So something that we could try is just taking this head pointer here and updating it on each iteration through a looping structure. So you could write something like this. You could say head and set head to just be equal to heads next. So what that's going to do is on the first iteration, we'll say that this is maybe an address 700 and this is an address 500. And the reason why I use those addresses is just to emphasize that these nodes here as part of a linked list, do not have to be in consecutive or contiguous memory locations. So this node here could be at a memory location that's actually before this node here. It's just depending on how that memory is allocated. So what would happen here is we would take heads next. So heads next would hold this address here. It would hold the address 500. That would be what next would hold, and we would be setting head to be equal to 500. So head would now be pointing to this particular node. And we could update that on every single iteration and start marching through our linked list. The problem with that, as you can see, is that we're losing what the actual head is. So we're actually modifying the head, and we have no way, no mechanism to get back to this very first node. So what we probably want to do is something very similar to that. And us being, programmers, software developers, one thing that we can do is bring things into existence anytime we need them. So we could create a pointer here and assign it to head, and maybe we'll call it traversal pointer, or maybe TP for short. So we could set a traversal pointer to being whatever head points to. And then we could do something very similar to what we just did. We could set traversal pointer on each iteration to be traversal pointers next. And that way we're not losing our head pointer, and we just simply have this traversal pointer that's allowing us to walk through or traverse through, visit each subsequent node in our linked list. So hopefully that makes sense. This is just like what we had whenever we had our head pointer here instead of our traversal pointer. TP would initially be set here to point to this very first node with the address of 700, and we would have next here that would hold the address of the next node, which in this case is 500. So we'd be setting 500 to TP after the first iteration through our looping structure. So each time, so that would allow TP now to be pointing here, and we would have updated it, and the next time it would be pointing here. So each time through it's pointing to the subsequent node. Hopefully that's clear. Let me go ahead and write a little bit of code here just to show you what our looping structure is going to look like. We would need to have some sort of condition. How do we know when we should stop? Well, one thing we could do is every time that we add in a node to our linked list, we could increment a size, and then you could use a for loop. But you don't even have to do that. And the reason why is you have this null value out here at the very end of our list. So what we could do is just say, as long as we're not looking at a null value, we know that we have more nodes in our linked list that we could be traversing to or getting to. So we'll say this. We'll say while our traversal pointer is not equal to null, and I'm going to just use 0 here. So as long as it's not equal to null, then we can do whatever operations. So the operations that we could be doing could really be anything. It could be just printing out a particular data member. It could be doing a comparison operation to figure out if we should be doing an insertion, or comparison to see if we should be doing a deletion. So it's up to us what we do here. So I'm going to just put a comment here and say some node operation, some operation on the node. So some node operation. And even though I have this expressed as just a single line comment here, this may be multiple lines of code in terms of what operation that we're actually doing there. But once we do that, the next thing we need to do, and we have to make sure we do this, is updating our traversal pointer. So doing exactly what we did up here. So setting traversal pointer equal to our current traversal pointer's values next. So once we do that, we can actually advance our traversal pointer to the next node and do whatever operation it may be. So this is the body of the while loop, and certainly before this while loop structure, we would have to be creating our traversal pointer and setting it to head, and then once we've done that, we can then have the while loop structure. So let's go over to Eclipse and implement a function where we maybe just print out the contents of our node. And maybe we'll also play around with the debugger a little bit just to see what's going on behind the scenes. So let's go over to Eclipse and do that. Alright, so I have Eclipse loaded up now, and I've also opened up some of the files that we have worked on in a previous video whenever we were trying to develop this very basic linked list data structure in C++. So I have contactlist.h, contactlist.cpp, and contactlist.app.cpp opened up. And what we want to do is just add in a function prototype for our print list function that we're going to be writing. And it's going to turn out that this print list function doesn't need to return anything, so we'll just perform the operation of printing our list out, and that will be it. So it's a void returning function. We'll call it print list, and it also is not going to take any parameters, so we have empty formal parameter list, and so that is it. So let's go over to the contactlist.cpp file. So right below our add to head function, we can start writing code for our print list. So it's a void returning function, It belongs to our contact list class. Use the scope operator, select it there from the drop down list, and now we're ready to start writing the body. So open brace, close brace. And what do we need to do? The very first thing that we need to do inside of this particular function is create our little traversal pointer, our TP pointer, to point to head. So since our linked list is composed of these contact nodes, we'll have to have a contact pointer for TP's type. So TP is a contact pointer, and we just simply want to set it to the head pointer. So whatever head's pointing to, TP is going to be pointing to the exact same node. And then we can have our while loop. So we'll say while TP is not equal to null, and I'll use 0 there to indicate null. And now inside this while loop, what we have to focus on is what operation we want to perform on the node that TP is pointing at. So in our case, we're interested in outputting the contents of our node, which is just simply a name. So we'll do a cout here, use the insertion operator, and then dereference that TP pointer to actually get to our contact node. If you don't dereference TP, then you'd just be outputting the address that TP holds, and we don't want to do that. And I'll remind you that we did overload the insertion operator, so we know what to do in the case of having an O stream on one side and having a contact on the other side. So let me just bring up the contact.cpp file, and you can see here that we did in fact overload the insertion operator, and we're just outputting name, string literal, and then the actual name of the contact. So we do have that in place. Let's go back here, and we'll also do an insertion operator indel, and then down below that we'll just simply update our TP pointer. So TP should now be set to TP's next. So we'll have TP set to TP next. If we don't do that, we will not be driving that TP pointer to the next node. And in the case of having, say, a linked list with a single node, or at least a single node, you would just sit there and stay on that very first node, outputting the same exact name over and over again if you did not have this line of code that we just wrote. So that pretty much wraps up our print list function. So let's go ahead and save that bit of code there, and we'll move over to our contact list app.cpp file. And just to do a quick review of what's going on in this file, what we had done is created a contact list here, and initially the contact list would be empty. It'd be created out there on the heap because we used the keyword new, and we have this pointer called CL1 that just simply refers to that contact list. So this is the way, if we want to do anything to that contact list, we do it through this pointer here, CL1. And then we have the while loop here. So in the while loop, we're just simply asking the user to input a name of a contact or Q to quit. And if they don't press Q to quit, then we'll pass in the name that they typed in to our add to head function. And then the add to head function will actually create a new contact node and add it into the head of the list. So that's what's going on inside the main function. And so now what we can do is focus in on just writing one line of code to call our print list. So that'll just be CL1, and then we'll use our member access operator, and then what we want to do is just simply print out our list and do a semicolon, and that is all we need to have for changes to the contact list app.cpp file. So I'm going to go ahead and save this and build everything to make sure it builds okay. And it looks like everything is building okay, even though it's taking my system a little bit of time there to build that. So instead of running this straight out, I think what I'm going to do is launch the debugger, and what we'll do is run straight through this code, and then we'll have a breakpoint here and step into the print list function. So I'm going to go ahead and launch the debugger. Okay, so the debugger has been launched, and I'm going to set a breakpoint here on line 27, which is our call to the print list function. So we'll go ahead and run it to that point. Well, first we need to, I guess, input some names. So we'll have Tom, we'll have Bob, and we'll have Sally. So, and then we'll do Q to quit. So now that we have that, we're here on the line where we're about to call the print list function. So I'm going to step into that function there. So we'll do a step in operation. So now we're in our print list function, and you can see over here in our variables window we have the keyword this, which this is just the keyword in C++ that refers to the calling object. And what we had going on here is we had created an instance of our contact list class called CL1, and so CL1 was the object performing this operation called print list. So this is actually CL1, and if we expand out the listing there, you can see head currently has a value there. This should be the address for Sally's node, since Sally was the last one that we added in. And we can probably see that if you expand that out and go far enough down. Let's see how far down we have to go. And eventually you get to, you get to Sally there. So you can see the data associated with those nodes. If you expand out the listings, you can see the size is 3, and you can see that we have this TP pointer here. So TP has been created, but this value right now is just some junk value. But as soon as we step over, so if we step over this line here, line 37, we'll see that this value of head here gets set to TP. So we'll do a step over operation, and you do see that we had 561BF0 assigned here to TP. So TP is not null. We'll get there inside of our while loop, and now we'll be outputting the contents there, which should be Sally's information. So we see Sally being outputted here to the console, and now we're about to update TP to be TP's next. So if we expand the listing here, you can see what TP's next is. This value is going to be assigned here to TP, and the next value will also be updated as well. So it'll be the next node. So we'll update that. So you see that both of those values get updated. And so this was what the value of next was previously, and next has now been updated to point to the next node. And we go back and get into the body of the while loop again after we test TP is not equal to null. And now we're going to do another output of TP. So I'm going to just kind of step through this. I think you guys get the idea. We got TP again that's going to be updated. TP is still not equal to null, so we get back in and we output the last node. In this case, it would be Tom that we typed in. So we'd output the contents there for Tom. And now we would update TP again. And so what will happen is the next value, which is now null, will be assigned to TP, and then next will not even have a value because we don't have any other nodes. We're actually falling off of our list at this point in time when we do this step over. But it's okay to fall off your list because we've done a test here to ensure that we don't go back into the body and try to output anything since there's no other nodes left. So we'll do one more step over operation, and we can see that, yeah, we didn't get inside the while loop. So we finish up with a print list function, and that pretty much wraps up what I wanted to discuss in this particular video. So I think it's kind of cool to open up the debugger and actually see those address values and see them being assigned correctly, and it just kind of, I guess, ties everything together and makes a little bit more sense to you if you can see what's going on behind the scenes. So hopefully from this video you have a good understanding of how to go about traversing a linked list, and we can really perform any operation we want to as soon as we're able to do a traversal. So I think an upcoming video will look at how to go about inserting a new node in our linked list at a particular location. So we'll be making use of this traversal idea. So that's it for this video.